Okay, here we are looking at the distance formula, and we're also going to look at equations of lines and some different things here. Okay, so the distance formula between 2 points, x1 and y1, x2, y2, is this formula right here, and this will help us find the distance between 2 points. So since this is a video, I'm going to kind of let you guys read as you go. I don't want to read to you in the video. That could be pretty boring. So let's go ahead and get busy on this first problem. You're supposed to decide whether it's isosceles, meaning 2 sides of equal length, equilateral, 3 sides of equal length, or scalene, which would be 3 sides of, oh wow, that's a typo right there, isn't it? Sorry. How about unequal? Maybe I should read these. Okay, so this is a good sign for the video. So let's find first the distance between P and Q. Let's find the distance between those 2 points. So we will do that by taking x2 minus x1, so really, and then squaring it. It doesn't really matter which one you start with, but I guess this can be our second one. So this will be -1 minus 6 squared plus y2 minus y1, -1 minus 6 squared. So this is the square root of -1 minus 6 is -7 squared is positive 49. Then you have another positive 49. Now, to be snazzy here, notice that you have 2 49s. So this is the square root of 2 times 49. And the reason I did that is because the square root of 49 is a perfect square. It's 7. So this is 7 on the square root of 2 is your length there. Now, the distance from P to R is equal to the square root of, let's see, do the R first, so -5 minus 6 squared plus 3 minus 6 squared. So this is -11 squared, which is 121. So the square root of 121 plus 3 minus 6 is -3 squared is positive 9. So this is the square root of 130. You want to try to simplify that, but if you think about the prime factors of 130, the largest number I can think that's prime that goes into 130 is 5, and that goes in, let's see, that'll be 26 times, and then this is 13 times 2. So the square root of 130 is the same as 5 times 13 times 2. None of those are perfect squares, or do they occur more than once? So the square root of 130 is just what it is. You can't simplify it any further. Finally, the distance from Q to R. So right now these two are not equal, so we know we don't have an equilateral triangle. From Q to R, let's see, that's going to be -5 minus -1 squared plus 3 minus -1 squared, and we're going to take the square root. -5 plus 1, that's -4 squared, that's 16. And then we have another 16 because that's 4 squared. So using the same logic as we did on that first one, that's 2 times 16, or 2 16s. And so that is going to be 4 on the square root of 2. So none of these are the same length, so our triangle is scalene. That was just a nice application of distance formula. Now we're going to look at this idea of finding x and y intercepts. You'll be doing this a lot in this class. Remember, to find an x-intercept, you just set y equals 0, because an x-intercept is where it crosses the x-axis. So notice on the graph over here that the y value is 0. To find a y-intercept, you plug 0 in for x and solve. So on this first one, the x-intercept is going to be 0 equals x squared minus 6x plus 8. We know that we will factor this as x minus 4 times x minus 2. So we get x equals 4 or x equals 2. Those are our x-intercepts. To get our y-intercepts, we'll plug 0 in for x, which is always more fun. Y equals 0 squared minus 6 times 0 plus 8, which is equal to 8. So our y-intercept is 8. Now on this next one, it's a little bit tricky. If you plug for the x-intercept, you plug 0 in for y. So x times 0 equals 1. When's that going to happen? Never. And the same is true for if you plug 0 in for x, 0 times y equals 1, that's also never going to be true. So it doesn't always have to have a solution. No solution is a solution. Okay, let's talk now about this idea of symmetry. Symmetry is just how the graph looks. Y-axis symmetry, you get the same y value when you put x and negative x in. You get the same y. For x-axis symmetry, you can fold it across the x-axis, so if you put y or negative y in, you get the same x value. And then for origin symmetry, when you put negative x and negative y in, you get what it says, a graph is symmetric with respect to the origin if for every xy on the graph, the point negative x, negative y is also on the graph, so you get exactly the opposites. All right, so what you want to do is say, go through these steps to test for symmetry. You're going to have y-axis symmetry if you plug negative x into the original equation and you got what you started with. You have x-axis symmetry if you place negative y and you got what you started with, and you have origin symmetry if you replace x with negative x and y with negative x and you get the same equation that you started with. So that's kind of confusing. Students have a little trouble with this. But for y-axis, you're just going to take this original equation and you're going to put negative x in it. So you're going to get y equals negative x squared plus 1. Well, the opposite of x, when you square it, is still the same as x squared. And that's what you started with. So yes, we do have y-axis symmetry. Now for x-axis, you do negative y is equal to x squared plus 1. Now if you solve that for y, you would need to divide both things by a negative 1 and you get y equals negative x squared minus 1. Well, that's not what you originally started with, which was x squared plus 1, right? You have minuses there. So you don't have x-axis symmetry. For origin symmetry, you need to replace y with negative y and x with negative x and see if you get the same thing that you started with. Well, this is going to be very similar here to what we have with x-axis. We're going to get negative y is equal to x squared plus 1, which would mean that y is equal to negative x squared minus 1, which is not equal to what we started with, which was x squared plus 1. So we also do not have origin symmetry. We only have y-axis symmetry on that one. Okay, next thing we're going to look at is this idea of the standard form for an equation of a circle. It's going to have this form x minus h squared plus y minus k squared equals r squared. Now the general form, all they do is they just kind of FOIL this all out and clean it up a little bit. They even move the r squared over and collect it because you're going to have some numbers there, and that's called the general form. And we're going to look at how to go back and forth between these two forms, or really mostly just to go from the general form to the standard form by completing the square. Let's do a couple examples here. It says find the center, radius, x-intercept, and y-intercept of each circle. So the standard form has x minus h, so you want to think of this as x minus negative 1, because that's the same as x plus 1. And then y minus 3 is fine. And then 16, of course, is 4 squared. So you get your center at negative 1, 3, and your radius is equal to 4. Now, to find your x-intercepts, remember, plug 0 in for y, and we're going to review a skill here, an algebraic skill to solve this. So we'll have the x plus 1 squared plus 0 minus 3 squared equals 16. So we have x plus 1 squared is equal to negative 3 squared is 9. And if we move that over, we will get 16 minus 9, which is, 7. Now, you can actually solve this with the principle of square roots because you can undo this squaring right now. You don't have to like expand that out or anything. Let me get some more room here. So this is going to make x plus 1 equals plus or minus the square root of 7. So x equals plus or minus the square root of 7 minus 1, because I'm just going to move that minus 1 over. So that is your x-intercept. You're going to use a similar strategy to get your y-intercept. You're going to plug 0 in for x. So you'll have 0 plus 1 squared plus y minus 3 squared equals 16. So this is 1 squared, which is just 1. So y minus 3 squared, I'm going to move that 1 over, is going to equal 15. So y minus 3 equals plus or minus the square root of 15. So y equals plus or minus the square root of 15 plus 3. So you'll see this is your y-intercept. You have two y-intercepts, you have two x-intercepts, and you have your center and your radius. Okay, now getting a problem from general form to the standard form involves a method called completing the square. What you want to do first is to kind of make sure that the coefficients in front of your squared terms are both 1. So you got to do some algebra first, techniques to kind of clear that up. But here we're fine with that. So then what you want to do is group your x term. So you have x squared, and then, sorry, that'll be minus 2x. And then plus, we're going to add a value here. So I'm going to leave a space. I'm going to have plus y squared minus 2x. And again, I'm going to add a number, so I'm going to leave a space. And I'm going to equal 4, so I move the 4 over. Now, the process of completing the square is to take half of the linear term. So half of 2 is 1. And then you square it. 1 squared is 1, and you add it right here. And what you've done is you've created a perfect square trinomial. This will factor as x minus 1 quantity squared. You do the same thing here. Half of 2 is 1, squared is 1, so you have a 1 there. So this is going to be y minus 1 squared. Now you can't just add numbers to equations and without doing it to both sides. So I'm going to have to add 1 plus 1 or 2 to this side, so I get 6. So my center is at 1, 1, and my radius is the square root of 6. Now, to find the x-intercept, we will plug 0 in for y. So I'll just do that right here. Your x-intercept is going to be y squared, you plug 0 in for y. So it's going to be x squared plus 0 squared, which is just 0, minus 2x, minus 2 times 0, which is 0, minus 4 equals 0. This does not factor, so you want to use the quadratic formula. So x is going to equal plus or minus, x is going to equal the opposite of b, which is 2, plus or minus the square root of b squared, which will be 4, minus 4 times a times c divided by 2a. So that's 2 plus or minus the square root of, 4 plus 16, which is 20 over 2. And let's clean that up a little bit. Let me get myself some more room. Okay, this is 20 is 4 times 5. And the square root of 4, of course, is 2. So this is 2 plus or minus 2 on the square root of 5 over 2. And remember, 2 divides into each of these. So this is 1 plus or minus the square root of 5. Okay, those are your x-intercepts. To get your y-intercept, you plug 0 in for x. So we'll plug 0 in for x, and we'll get y squared minus 2y minus 4 equals 0. Well, look at that. That's kind of exactly what we started with. So we could do all this work, but we would see that our y-intercept is 1 plus or minus the square root of 5. Okay. On this next problem, what you want to do first is notice that you can divide all of these by 3 to simplify it. And this will be x squared plus y squared plus 2x equals 0. Then you want to group your x together. Remember, you're going to add a number there, so we'll leave space. Plus, now in this case, y squared, it doesn't have a y. It doesn't have a linear term, so this is just kind of like y minus 0 squared. So you know the y coordinate of the center is 0. Again, you take, this is a similar problem, you take half of 2, which is 1, squared is 1. So your perfect square trinomial is going to be x plus 1, its factors is x plus 1 squared plus y squared. But remember, you have to add 1 to this side because, see, you take half of 2 and you square it, and that's where we got the 1 from. That's how we figured that out. Okay? But we have to add it here as well because you can't just add 1 to both sides. Okay. I mean, you can't just add 1 to one side. You have to add it to both sides. Okay, and so this will be like x minus negative 1. So our center is at 1, 0, and our radius is the square root of 1, which is just 1. Now, sorry, this is negative 1 because it's x minus negative 1 squared. That's how you want to think of it. Now, to get your x-intercept, plug 0 in for y. You're going to get 3x squared plus 6x equals 0. And actually, you could have done it here. Anyway, it doesn't really matter. I'm going to factor the 3x out, and I'll get x plus 2 equals 0. And then I get x equals 0 or negative 2. That's my x-intercept. I have two x-intercepts at 0 or negative 2. And then my y-intercept, I'll put 0 in for x, and I'll get 3y squared equals 0. So then y is just going to equal the square root, divide plus or minus square root of 0, which of course is just 0. It doesn't have more than one answer. Okay. All right, now let's move on to the next thing, which has to do with lines. Again, I'm not going to read this all to you because I know that you can read it, but the slope of a line is the rise over the run. It's the change in the y over the change in the x's. So you subtract your y's, you subtract your x's when you look at 2 points. If you scan a graph from left to right, it's going to have lines with positive slopes rise and lines with negative slopes fall. The greater the absolute value of the slope, the steeper the line. If you have a horizontal line, the slope is 0. If you have a vertical line, the slope is undefined. Now, parallel lines have the same slope. So parallel lines have the same slope. Perpendicular lines, when you multiply them, their slopes have negative reciprocals. So an example of that would be like if you have a slope of 5, the slope of the line perpendicular, and I'll draw a little right angle there, would be negative 1/5. Because when you multiply 5 and negative 1/5 together, you get negative 1. Okay, now we can just actually count the rise over the run to get the slopes of these lines. So L1 is the red line here. I want to rise 1, 2, 3, 4, 5, 6, 7, and then I run 1, 2, 3, 4, 5, 6, 7. So 7 over 7, which is a slope of 1. L2, if I find 2 points on L2, I don't even have to. Notice L2 is a horizontal line, so it has a slope of 0. L3, from this point to this point, I go 1, 2, 3, 4, 1, 2. So it's rise 4, run 2, which reduces to a slope of 2. And then L4 is, let's see, notice it's a downhill line. It's going to have a negative slope. If I go from this point to this point, I'm going to go 1, 2, 3, 4, 1, 2, 3. So negative 4/3. Or you can, because I'm going down 4 and right 3. Or just know that it's negative. Okay, we have 3 equations for a line. We have the point slope equation. So if you have the slope and a point, this is a real nice equation to use. If you have the slope intercept, whenever you're given the slope and the y-intercept, this is a real nice equation to use. And then this is the general form of line, which you don't see very often, but it comes up here and there. So I just wanted to show it to you. Notice the equation of a horizontal line is always going to be y equals k, whatever the y coordinate is. And the equation of a vertical line is always going to be x equals h, whatever the x coordinate is always the same value. So this is a nice little side note. It says sometimes students find it easy to remember that if in a linear equation, if it does not have a y in it, the graph is parallel to the y-axis, and if it does not have an x in it, the graph is parallel to the x-axis. So if you think about like this line right here, call this the line x equals 2. Notice it's parallel to the to the y-axis. It doesn't have a y in it, so it's parallel to the y-axis. And here, if you think of this line, maybe y equals -3, it's parallel to the x-axis. So something to think about. Okay, so now we want to find the equation of this line. You want to begin by looking at the slope. We have 2 points, so you look at the change in the y or the change in the x. So 3 minus 3 over 3 minus -1. Immediately you see that the slope is 0. When you have a when you have a slope of 0, it's going to be a horizontal line. So the equation of the line is just y equals whatever the k is. Notice you have the same value. You're always going to, for horizontal lines, the points on the line always have the same y value. For vertical lines, the points on the line always have the same x value. That was pretty easy. Okay, now we need to find the slope on this one. Notice they gave us the y-intercept, so that's a nice thing because we'll be able to use the slope-intercept form as soon as we find the slope. Okay, so we'll do 2 minus a half, just kidding, because it's the y value, so how about 2 minus a fourth? That sounds better, doesn't it? Yes. 2 minus a fourth over 0 minus a half. Okay, 2 is the same as 8/4 minus 1/4 over 1/2. So 8/4 minus 1/4 over -1/2. 8/4 minus 1/4 is 7/4 divided by -1/2. And when you have a fraction divided by a fraction, you want to write that as 7/4 times, and you flip that 2 over -1. Then you can reduce. 2 goes into 4 2 times. So the slope here is -7/2. Now, this point slope formula is y equals mx plus b. So, or this is the slope intercept formula, so we have everything we need here. Y equals -7/2 x plus b is the y-intercept, which in this case is 2. So we are good to go on that problem. Let's try the next problem. We have an x-intercept of -5, 0. So that, of -5, 0, that's the point. And the y-intercept is -2, so that's 0, -2 is the point. So to get your slope, it's the change in y, so you could do -2 minus 0 over the change in x, 0 minus -5, which is -2/5. And then again, you can use the slope-intercept formula because you know the y-intercept is -2, and now you know the slope. So this is going to be y equals -2/5 x minus 2, or plus -2 works. Okay, now we want to find the equation line parallel to this line passing through 1, 1. In order to find the slope from a line that's given to you in this form, it's best for you just to solve it for y. So if you solve this for y, you get y equals 1 minus x. The slope is always the number or the coefficient in front of the x term, so in this case the slope is -1. Now, if the lines are parallel, we're going to have the same slope. So we have the point and we have the slope. We're going to use this point slope formula to get the equation of the line. So it'll be y minus 1 equals -1 times x minus 1. Or let's do this in our head then. This is going to be negative x, and then that's going to be plus 1. We move that over, that's going to be plus 1, so it's going to be y equals -x plus 2 is the equation of the line that's parallel. To find the equation line perpendicular, again, we need to first find the slope. So 3x minus 9y equals 18. Negative 9y equals 18 minus 3x. So y is equal to -2 plus 1/3 x. Because I divided each of these by -9, that would make -2, and -3 over -9 is positive 1/3. So the slope of the line perpendicular is going to be -3, because it's the negative reciprocal of the slope of this line. So now we have our point -2, 4, so we're going to say y minus 4 equals the slope m onto x minus -2. So we have y equals, this will be -3x. Now this is plus 2 times -3, which is -6, and then plus 4, so that's going to be -2. -3x minus 2. Okay, here's a little word problem. It says after 5 months, the number of viewers of the weekly show was 5.73 million. After 8 months, the number of viewers of the shows rose to 6.27 million. Assume that the linear model applies. Write an equation expressing the number of viewers V after X months. So what we can do is we can do an X and a V instead of an X and a Y. We'll have the points 5 months, we had 5.73 viewers, and 8 months, we had 6.27 viewers. So to get the equation in line, we'll first need the slope. So it's going to be 6.27 minus 5.73 divided by 8 minus 5. So you're going to have to do that subtraction. 6.27 minus 5.73, that'll be a 4 here. We'll change this to a 12 and this to a 5. So that's going to be 0.54. So this is 0.54 divided by 8 minus 5, which is 3. And we don't want to leave a decimal over an integer, so we'll go ahead and divide 3 into 0.54. So we bring up the decimal here. 3 goes into 5 one time. And then when we subtract, we get 24. 3 goes into 24 8 times. So 0.18 is your slope. So your equation for your line is going to be V minus, and you choose either point, so I'm going to choose the first one, 5.73 equals, so this is like y minus y1, equals m, which is 0.18, times x minus 5. So we have to do a little bit of work here. 0.18 times 5 is 0.90. So we have V is equal to 0.18x. So this is minus 0.90, and then you're going to add plus 5.73. And 5.73 minus 0.90, let's do that subtraction. So 5.73 minus 0.90, that's 3. Change this to 17 and change that to a 4. So that's 4.83. So V is equal to 0.18x plus 4.83. So that's your answer to A. Let's see if I can get this to move down a little bit. Okay. On B, it says interpret the slope and the slope and the intercepts of the line in part A. So the slope represents the monthly change in the number of viewers. And the y-intercept represents the number of viewers when the show started. Okay. And then let's see this next one, part C. Says how many viewers will it have after 11 months? So you're going to do V equals 0.18 times 11 plus the 4.83, and so 0.18 times 11, that's 8, and then 1081, so 891, and you add a decimal right there, so 1.98. So you're going to add 4.83 and 1.98, and that's going to be 6.81 million viewers. Okay, and then we just have a couple questions left. I lost my question. Let's see. It said perform the indicated operation. And these are actually, there aren't any of these on your homework, so you want to pay attention to these last two problems because they show up, I guess the textbook, they were in the textbook and on the problems list, but they weren't, I couldn't find any on the online homework. Remember that this factors as x plus 1 times x minus 1. So we basically just want to get a common denominator here, which is going to be the factor that appears the most often in any one term. So this one just has a factor of x minus 1, but here we have a factor of x plus 1 and x minus 1. So you need to multiply this by x plus 1 over x plus 1. And so you'll get 2 times x plus 1 minus x all over x plus 1 times x minus 1. So this makes 2x plus 2 minus x over x squared minus 1. And so that makes x plus 2 over x squared minus 1. I got the x squared plus minus 1 just by FOILing that out. Okay, on this other one, want to practice the fraction a little bit. You want to get a common denominator in your numerator, which will be x over x, and a common denominator in your denominator, which is going to be x squared over x squared. So you're going to have 1 over x minus x over x divided by x squared over x squared minus 1 over x squared. So this is 1 minus x over x divided by x squared minus 1 over x squared. And that's going to be 1 minus x over x times x squared over 1 minus, I'm sorry, when I multiplied this by x over x, this should have been an x squared. So this is 1 minus x squared in the numerator. And, okay, so this is 1 minus x squared over x times the reciprocal here, which is x squared over x squared minus 1. Now, when they are exactly the same but just opposite sign, like you have 1 minus x squared and here you have x squared minus 1, you actually can cancel these as long as you introduce a negative 1. And then here the x squared and the x can cancel one of the x's in the denominator, and so you end up with just negative x on that problem. Okay, so I hope you made it through the whole video. I don't know if I could think of something fun to say at the end of the video. My cat's name is Kung Fu Panda, or Po, because he's black and white and super cute. Okay, talk to you later. Bye.